So we have now seen how to find the dimensional formula for a specific quantity. But what use is dimensional analysis? That's basically what we are going to see. Because once you have learned dimensional analysis, you will be able to quickly find out the formula from a broad picture. You will be able to actually narrow down to what the actual formula itself should be. So for example, suppose I come up with some formula which says velocity of an object as a function of time is given as kt plus pt cube. Suppose that was the velocity of an object. I am not saying it in a real case. Suppose this was the case like this. Now, one important thing, you can multiply two quantities which are very different. Force is mass into acceleration. How many times have you seen a formula which says some quantity like force is mass plus acceleration? You will never find such a formula, not in physics. Why? It is very good to multiply and divide physical quantities which are different. But you can only add and subtract quantities that are the same, which means dimensional formula of V must be dimensional formula of KT plus dimensional formula of PT cube, which means this fellow and this fellow and this fellow must all have the same dimensional formula. Is that clear? That's very important. If I had multiplied the two, that is okay. This dimensional formula into that dimensional formula is that dimensional formula. But when I am adding this and that must all have the same dimensional formula. This is called the principle of homogeneity. All of them, you can only add things that are of the same kind. Okay, you can't add things that are different. But you can multiply things that are different. That's weird, but you can. Okay, so let us look at this. What is the dimensional formula for V? It is length by time, LT power minus 1. That must be equal to dimensional formula of K into time. Separately. Similarly, LT power minus 1, which is the dimensional formula for V or this, must be equal to dimensional formula for P into T cube, time cube. What does this first one tell me? It tells us that dimensional formula of K is LT power minus 1 by T, which is LT power minus 2. So K must be of the form acceleration. It can be 2 times acceleration, it can be half, right? For example, you know that you can write this as half AT, sorry, not half AT, that will be for time square, for displacement. You can write it as A into T. You know V equals U plus AT. The AT has the same dimension as V. If I come to this one, this is PT cube. So that basically tells you P must have dimensions of L T power minus 4. This is not acceleration. This is not even the rate of change of acceleration. This is the rate of change of acceleration. Okay. So rate of change of acceleration is called jerk. So this is called the rate of change of jerk. Okay. I just cooked up something. So the basic idea that you see here is that this dimension, that dimension must all be the same. Instead of a plus, if I had put a minus, again it must be the same. But if I had put an into or a division, then this dimension must be equal to that whole thing's dimension. Piece by piece, it need not be equal. Only for addition and subtraction, every piece must be equal. They must all have the same dimensions, otherwise you can't add them. Okay, so I hope that is clear. Now we can use this to find a complete equation. For example, look at this question. Here I am telling you energy of a particular system is pressure power A into volume power B plus 3 times mass into some velocity of some object power C. I don't know what is M, I don't know what is V, I don't know what this pressure volumes are. In fact, I don't even know where this formula comes from. I don't know whose formula is this. That is the power of dimensional analysis. You don't need to know any other detail. You know this is energy, right? Now energy is the same dimension as half mv square or force into work. Let us use mv square. Half mv square is energy, so mv square must be energy. Now the dimensions of mv square must be equal to the dimensions of p power a, v power b, and must be the dimensions of 3 doesn't matter, m, v power c. Just by comparing, what can you say? C must be equal to 2. So C is equal to 2. I didn't even come to the dimensions part. Now similarly, this dimension and this dimension must be the same. Now what about this fellow's dimension? mass L by T, V is L by T whole square, so L square by T square, which I'll write it as L square T power minus 2. This must be equal to P power A, V power B. Okay, now let us think about P. Now what about P? I can write P pascals, right? Pressure. Pressure is force by area. So force is mass into acceleration by area, which is length square. This area is different, so I'll write, it's not amperes, it's just area. So mass is m, acceleration is L T power minus 2. So generally it's a good idea to remember the dimensions for force, newtons. M L T power minus 2 by area, which is L square. So what about pressure? Pressure is m L power minus 1, 1 and by 2. So 1 minus 2 is minus 1. So m L power minus 1 T power minus 2 whole power A, because it's P power A, into V power B. V is the volume. Volume is L cube. So it is L cube power B. You understand what I have written? I have written that the dimensions of P power A, V power B and the dimensions of mv square must be the same. Now this turns out to be very useful because we can use this to solve. For example, how many m's do you have here? 1. How many m's do you have here? M power A, so A. This is m power A. L power minus A plus 3b, so it is 3b minus A. T power minus 2A. Now this thing and this thing must be equal, but the whole idea is no amount of length, whatever you do here, it is not going to produce m. So who will produce this m? This. This m and that m must be the same. This cell and this cell powers must be the same. This T, that T powers must be the same, because time cannot create mass, mass cannot create length, length cannot create time, so you can't go from one to the other. So if there is mass here, it must have come from mass there, so A must be equal to 1. But if A is equal to 1, look at this, what is this? T power minus 2. Does it match? Okay, L power 2, so 2 must have come from L power 3b minus A. So 3b minus A. But remember A was 1. So if I put 1 here, that means 3b minus 1, take it to this side, you're going to get 1 plus 2, 3, 3 by 3, 1. So B is also equal to 1. So that means this formula, I can complete this formula and I can write U is P power A, P power 1, V power B, which is V plus 3m speed square. Speed square. Right? Now if you notice this, I started out with P power A, V power B. I found it must be P into V, which is very powerful because it helps you find out what it should look like. Okay, we'll take one more example to understand this. What dimensional analysis does is that it allows you to find things like A, B, C here, even if you don't know them. You just need to know what the dependencies are. You can find the exact relationship, not in all cases, but in many cases. We are assuming that this constant here was 1, this constant is 3. If you have constants whose dimensions we don't know, but they could have dimensions, then we are in trouble. But in otherwise, almost all the cases, you will be able to find out what kind of the formula you have except for constants. So let us try out a couple of simple examples. So here is a question where there is a planet that is going around the sun. And we know that the time period, the time it takes to go around T is going to depend on R, which is this radius, assuming that this is a circular orbit. It depends on the mass of the sun. It also depends on G, gravitational constant. But I don't know how it depends. It could be, so look at the possibilities. T could be some constant K times root of R m square G cube. Or it could be some K root of R m square by G. or it could be k times root of m r cube by g square. So many possibilities. I don't know which one is the correct one. Okay, now finding constant k is a tough task. Of course, it requires measurement, but even finding the form of the function is a hard job. This is where dimensional analysis comes to our rescue, and if we assume that this constant k is dimensionless, we can solve for it. So for example, I am going to say t is some constant k with no dimension. This is an important assumption. It depends on r, so it must be r power something a. It depends on m, so it must be m power b, and it depends on g, so it must be g power c. Now I want to find out what is a, b and c. Now dimensions of t, of course, is t, right, time. Dimensions of k, nothing, so I will ignore it. It is dimensions of r is length, so length power a. R power a is length power a. Mass power b. But wait a minute, what is g? Do you remember the formula for g? G m1 m2 by r square is f. So g is f into r square by m1 m2. And so dimensional formula for g is dimensional formula for f into dimensional formula for r square by m square. But f, if you remember, it is newtons, right? Remember, it is kilogram meter per second square, m L t power minus 2. Now this is not something you want to derive every time. Force is something you should know, you should remember. Into L square by m square. So you can see that there is an m power minus 1. So I will directly write it here, m power minus 1, okay, L cube, and then t power minus 2 whole power c. This has one t, there is no m. So this is m power 0, L power 0. So what is m square power exponent here? B, m power b, m power minus c. So m power b minus c must be 0. First equation. Let us now equate the coefficients, powers for L, not coefficients, powers for L. Look at this. L cube power c is L power 3c. L power 3c. This is L power a plus 3c. That must be 0. And then let us look at t. T is t power minus 2c. So this is minus 2c. There is no more t anywhere. So this must be equal to 1. So what does this tell us? This tells us c must be equal to minus half. But if c is minus half and I substitute c is minus half, I will get minus 3 by 2, take it to that side. A must be equal to plus 3 by 2. And then because I know b is equal to c, b must also be minus half. Now this is very powerful because it's telling me the exact formula. So now I know t must be equal to a constant times k times r power a, that is r power 3 by 2, r power 3 by 2. I am not saying r power something, I am saying r power 3 by 2. So it's a very precise answer. R power 3 by 2, m power b, which is m power minus half, g power minus half, right? So minus half is basically 1 by, right? So 1 by m power half, g power half, so root of mg. Okay, so you see what we have done, we have come up with a formula for the time period of rotation, revolution of a planet, k times r power 3 by 2 by root of mg. All we used was it depends on r, m and g, that's it. I don't have to figure out these things are things that we are calculating. Do you understand? So the moment you know r depends on just or t depends on just a few things, you can find out what the dependency formula must be. There is an important assumption that the constant is dimensionless. Okay, if it was like Newton's law of gravity, that kind of a constant, a physical constant, it has dimension. So we say these are just equation constants. Okay, these are dimensionless numerical constants. These fellows are called physical constants. So they do have dimensions. So, but there are many constants that do not have dimensions. We will be mostly dealing with those. Okay. Let us take one more example just to understand this. So, now let us take this simple pendulum. So, if you look at this simple pendulum, it makes oscillations, it goes back and forth, right? Now, the time period of this oscillation depends on the length. For example, if I had made this a very short pendulum, you can see that it goes back and forth quickly. If I had a longer pendulum, it takes a while to go back and forth. It actually does not depend on the amplitude. If I did this, it takes almost the same time as if I left it from here. If I left it from here, you can see that it is almost the same time. It is going slowly, but it goes less distance and it comes back, so it turns out that it basically doesn't take too much time. It doesn't depend on the mass, it depends on the length, it depends on G. Okay. Now, lots of studies will be able to tell us, experiments tell us that T depends on the time period of oscillation, depends on the length, depends on G, and actually does not depend on mass. But just by chance, let us say we assume it depends on mass. Okay? Then I will say T must be equal to, whenever you say it depends on length, G and M, it depends on the product of these things. L power something into G power something. It is not L power something plus G power something. Okay? So it depends on all of them. So therefore together it depends on all of them, basically means multiply. L power A, G power B, M power C into some constant K. Now some of you may already know the formula for this. The formula should be T is equal to 2 pi root of L by G. Okay, you can derive this as a formula, including the 2 pi. Now that's a lot more work. We will later worry about how to derive a formula like this. This is the time period of oscillation of a simple pendulum. Galileo had come up with a lot of detailed work on some of this. What is important is it does not have the mass. But I am now assuming that it has mass. So what do you think will happen when we do the calculation? C must turn out to be 0. Okay. And it could have been L into G, it could have been L power 3, G power 7. But no, it has to be root of L by G. So it has to be L power half, G power minus half. So if I solve this, I should find A must be equal to plus half, B must be equal to minus half, and C must be equal to 0, because that must be the formula. I won't be able to find K, that is the constant, and that turns out to be 2 pi. It's not going to be something you can find using dimensional analysis, but you would have found out it must be K times root of L by G. Let us first find that. I'm telling you the answer up front because most people already know the answer. What I'm going to ask you to do now is to derive it carefully step by step. Let us do that. Dimensions of time is of course T. Dimension of K we are going to ignore. We'll assume K is a dimensionless constant. Okay. Dimensions of L, length L. So L power A. What is G? G is acceleration. Remember, acceleration is what? Length by time square. So L by T square. So this is L T power minus 2 power B. So L power B, T power minus 2B. M power C. Correct? So now if I combine, I can say M to the power of C, L to the power of A plus B, T to the power of minus 2B must be T to the power of 1, and there is of course M power 0, L power 0. So you know that mass must basically correspond to mass. So C must be equal to 0, and then A plus B must be also equal to 0, and minus 2B must be equal to 1. So this tells you B must be equal to minus half. A plus B is 0, so this basically means A must be equal to plus half, and we have already found C is 0. So if I substitute that in here, I am going to get T must be K times L power half, which means root L, right? B is minus half, so G power B, So g power minus half, which is 1 by root g. So I'll write it like that, and m power 0, so that doesn't come. So you see that this formula matches the exact formula that you have. The only difference is you can't find 2 pi, you will just say k times. Again, let me emphasize that this works only when the constant is dimensionless. So is this a very powerful tool for solving all kinds of formulas? Actually, no. You will get this in exams. In exams, they will tell you that there is a dimensionless constant. You will assume the constant is dimensionless. It will say t depends only on these things. K is dimensionless. You make an assumption. But in reality, how do you know it only depends on this? Maybe the constant itself has a dimension. We won't know it. But we will make a guess. We will try and find a formula and then check. And remember, whenever it depends on multiple factors, it depends on A and on B, not this A, some factor A and factor B. That means together it depends on product A into B. Okay, that A itself may be A power 2 or A power 3 by 2 into B power 7 by 3. Right? But it is a multiplication of the two factors and not an addition of the two factors. Okay? Because generally when something depends on multiple factors, you then multiply the things that it actually depends on. So it varies with L power A, G power B, M power C. So together it is K times L power A into G power B into M power C. So I hope this is clear. So now let us, in the next concept, what we are going to do is to see how to apply this when we have slightly more complex versions of formulas.